Hello everyone, I hope all of you are good. Welcome to my channel Strong Math. Today's topics are existence of limit, right hand limit, left hand limit, algebra of limit, formula of limit and some examples. This is the second part of limit. If you have not watched the first part of limit, go to the link and watch this video.
Values of x approaches towards 0, then the values of y also approaches to 0. Similarly, if we approach from the negative side of x-axis towards 0, then the values of
In the previous video, we have discussed about the tends to. Let's recall, suppose this is a point 0 and we are denoting x tends to 0. X tends to 0 means the values of x are approaching towards 0. Now remember, values of x can approach from the right hand side towards 0, which we have already denoted like x tends to 0 plus. X tends to 0 plus means from the right hand side of 0 towards 0. And another one, x can be approached from the left hand side of 0, which we can denote x tends to 0 minus. So the negative sign here indicates the left hand side of 0 and the positive sign of 0 gives us the right hand side of 0. So x tends to 0 plus is from the right hand side towards 0 and x tends to 0 minus means from the left hand side towards 0. Now today at first we will discuss about the right hand limit and left hand limit. For that, let's take an example. Suppose f of x equals to mod x. All of you, I hope, know about the definition of mod x. If you don't know the definition of mod x, please go to the given link for some important functions. You can learn about the definition of the functions, their domain range and their respective graphs. Okay, I have given the link in the description. Okay students, now fx equals to mod x. The definition of mod x is x if x is positive, mod x is 0 when x is 0 and mod x is minus x when x is less than 0. We are going to check at x equals to 0. Okay, what is the meaning of right hand limit and left hand limit? The right hand limit is denoted by limit x tends to from the right hand side towards 0. Okay, that means x tends to 0 plus f of x gives us the value of the function fx where x is approaching from the right hand side towards 0. Now look, if we draw a rough sketch of the number line, suppose this is the point 0. Now from the right hand side of 0 towards 0 is x tends to 0 plus, and from the left hand side towards 0 is x tends to 0 minus. Now look at the function. When x is greater than 0, the value of the function is x. So from the right hand side towards 0, the value of the function is x. Now when x is approaching from the left hand side towards 0, the value of the function is minus x. And at 0, the value is 0. Okay. So we have to consider the function according to the side of the point. Here we are taking x tends to 0 plus, that means from the right hand side of the 0 towards 0, and the value of the function in this region or in this portion, that is from the right hand side of 0 towards 0 is x. So we will write limit x tends to 0 plus value of fx here is x. Okay, and we can put the value of x here x is tending to 0, there is no indeterminate form. Okay, we will discuss about indeterminate form later. So limit x tends to 0 plus, then we can put the value of x here, which is 0. You have to put the value only. Plus sign indicates the direction of x from where x is tending to the point 0. Similarly, for the left hand side, that is left hand limit x tends to 0 minus f of x. Limit x tends to 0 minus, look at the definition of the function. When x is less than 0, that is from the left hand side of 0 towards 0, the value of x fx is minus x. So here we will write limit x tends to 0 minus, and value of the function in this portion is negative x. Now value of x here is also 0. The negative sign indicates the direction only. So value of x we have to put 0 here. Minus 0 is 0. Now look, the left hand limit is 0. The right hand limit is also 0. Now we are discussing about the existence of limit. When the limit of a function exists, limit of a function exists if right hand limit and left hand limit both are equal. So the basic criteria of existence of a limit of a function at a given point is the right hand limit must be equal to its left hand limit. That is, suppose at x equals to c, we are checking the limit of a given function if y equals to f of x. So the criteria is if limit x tends to c plus, that is right hand limit of the function fx at the point c is equals to left hand limit, that is limit x tends to c minus f of x. If both the limit exist and equal to each other, suppose the same value is L, then we can say that limit of this function, limit x tends to c f of x equals to L. Okay, remember in the previous video, that is in the part 1, I have given 2 or 3 examples of how to find the limits of a function. We have only, suppose for example, limit x tends to 2x square. We can easily put the value of x equals to 2 here, then we will get 2 square equals to 4. How can we write limit x tends to 2x square equals to 4? Because in this case the right hand limit of this function at 2 and the left hand limit of this function at 2 both are equal and equal to 4. That's why if for a function y equals to fx at x equals to c, the right hand limit, that is limit x tends to c plus, this value is equals to the left hand limit, that is x tends to c minus f of x. If both are equal and equal to L, then we can write limit x tends to c, look, limit x tends to 2, f of x equals to L. Here f of x is x square. So we can put the value here directly and get the value of this limit is equals to 4. That's it for right hand limit and left hand limit and the existence of limit. Let's discuss another example. Fx equals to x square minus 2 when x is greater than 1. Fx equals to 0 when x is 1 and fx equals to x plus 1 when x is less than 1. So if we draw the number line, then clearly you can imagine, suppose this is the point 1. Now look, if we approach from the left hand side towards 1, that is from the left hand side of 1 towards 1, and we write it x tends to 1 minus, the minus or the negative sign indicates the direction left hand from the point 1 towards 1, and the value of the function here is x plus 1. So this is x plus 1. Suppose at x equals to 1 the value is 0, at x equals to 1 value is 0. So suppose this is 0. Now if we approach from the right hand side towards 1, then the value is x square minus 2, and we denote it like this: x tends to 1 plus, and value of the function is x square minus 2. So this is the rough sketch of this given function. You can easily take the values. Okay, now suppose we are going to find out the right hand limit and left hand limit. Now right hand limit is equals to limit x tends to, we are checking the limit at x equals to 1, okay, whether the limit exists or not. Now at x equals to 1, right hand limit is limit x tends to 1 plus, okay, f of x. This equals to limit x tends to 1 plus, x tends to 1 plus. From the picture you can easily guess the value of the function, and you can see that for x tends to 1 plus, the value is x square minus 2. In this way you have to select the value of the function. From the right hand side of 1 towards 1, the value of the function is x square minus 2. Okay, we have indicated the values in the red color for x tends to 1 plus. Okay, and the value of this limit will be, we have to put the value of 1. 1 plus means direction. So this is 1 square minus 2, which gives us minus 1. Okay, fine. Now for the left hand limit, we have to calculate the left hand limit. The left hand limit of the function, limit x tends to 1 minus, from the left hand side of 1 towards 1, and we have denoted the function in blue color. So f of x is equals to limit x tends to 1 minus, minus sign denotes the left hand side. Okay, so the value of the function in this region is x plus 1. Okay, so the value of the function is, we have to put the value of x, the point is 1, the point is 1. Don't put minus 1 here. Sometimes you do a mistake by putting the negative sign of the point here. Don't do mistake. You have to put the value of x is 1 here. So 1 plus 1 equals to 2. Okay, try to remember that 1 plus or 1 minus gives us the direction. Okay, from which direction x is approaching towards the given point. Here the given point is 1, and the plus sign and minus sign denotes the direction. So clearly here, look, the right hand limit, value of the right hand limit is minus 1, value of the left hand limit is plus 2. They are not equal. Okay, here we can write left hand limit is not equals to right hand limit. Okay, so by the criteria of existence of limit, it is clear to you, I hope so, that this limit, which limit? Limit x tends to 1 f of x, this limit does not exist. Does not exist. Why? Because by the criteria of existence of limit, we have already learned that if right hand limit and left hand limit both are equal, then we can say that the limit exists, and the value of the limit will be the same value. As right hand limit and left hand limit both are not equal in this case, so the limit of the function fx at x tends to 1 does not exist. I hope you can understand. Let's move on to our next topic, algebra of limit. Suppose we are taking two functions, limit x tends to c f of x, which exist and value is suppose L1, and limit of another function at the same point, suppose gx, exists and equals to L2. These two limits are exist. Okay, now the algebra of limit gives us some laws or rules. Number one, if we add them, that is limit x tends to c f of x plus g of x, we are taking the summation of these two functions, then this equals to the sum of the limits of the functions respectively, that is limit x tends to c f of x plus limit x tends to c g of x. So limit of sum of two or more functions, this is valid not only for two functions, you can add infinitely many functions. Okay, limit of their sum is equals to limit of the functions, sum is equals to sum of the limits of their functions individually. Okay, now similarly limit x tends to c f of x minus g of x, that is we are taking the limit of the difference of two functions, which is equals to limit x tends to c f of x minus limit x tends to c g of x, that is limit of the difference of two functions is equals to difference of their limits. Okay, similarly for the multiplication, that is limit x tends to c f of x into g of x is equals to limit x tends to c f of x into limit x tends to c g of x, product of two functions. We are taking the limit of product of two functions. Limit of product of two functions is equals to product of their limits. Similarly for division, if we take the limit of the division of two functions f and g, that is fx by gx is equals to limit of fx by limit of gx at the same point, that is x tends to c. Okay, you have to remember that here gx is not equals to 0, provided gx not equals to 0 and the limit of gx, which is L2, is also not equals to 0. As if gx becomes 0 or the limit of gx becomes 0, then the division will be undefined. And there is another law, which is number 5, limit x tends to c k into f of x is equals to k into limit x tends to c f of x, where k is any constant or scalar. Okay, k is any constant or real number. So these are the algebra of limit, these are the properties or rules. Okay, in the next video we will discuss about some rules or formulas. Look at the screen, this will be the topic of our part 3 discussion. So stay tuned with this channel. If there is any kind of doubt or problem related to today's lecture, please comment below. Thanks for watching this video. Please like, share and comment, and obviously please do subscribe my channel Strong Math. Mention your query, keep watching. Thank you.